So when you look at that question which they have given us, which will be our first question on projectile motion. So if they have given you that question, what should you do? First, identify the case. So indeed, you can agree with me. This is what you are calling the first case, because I said the first case is when someone is standing on a cliff, throws something when it comes down. That is the first case. So similarly here, it is the first case. After that, we collect data. So when you read this question, there says an airplane is flying horizontal with a constant speed, which is v initial 400 km per hour. So you correct the data. Yes. So you correct data. You know our v initial is what? So v initial, it is 400 what? Kilometer per what? Per hour. So we are just correcting the data, and they continue at a constant elevation. So the height or the elevation here, it is what? 2 kilometer. Yes. So first thing, you just correct data. After correcting data, then you read the question which they want us to answer. So the question there, they ask us, if the pilot decides to release a package so that it lands very closer to a track on the ground, determine the time of flight of the parcel. So the first thing they ask us is to determine what? The flight of the parcel. But when you look at here, our velocity is what? Is in 400 km per hour, and our height is in 2 km. So me, to answer this, what I do, I just convert this velocity into meter per second. And converting velocity into meter per second is very easy. So what I do when I'm converting this, I say 400. I know it is in what? Kilometer. That's what I do over. So I do over what? I'll just do over what? Hour. So me, I'm just converting this into I want to convert into meters. So then I'll just multiply. First, I'll start with this. How many meters makes 1 kilometer? So I do 1. So I'll do 1. So I'll say 1,000 what? 1,000 meter over, which is kilometer. So which is 1 kilometer makes 1,000 meters. And then I'll just do this. This is hours. So how many hours makes we are converting to second, which is 60 times 60, which is 360. So I do 360. So 360. So I'm just converting this. So I want hours to cancel. So I do 1 hour. Here will cancel with 1 hour. 1 hour. So I put 360. Yes. So second. So here when you do this, hour will go. Even kilometer will go. So then you just multiply here. So when you multiply here, the answer which will give you, it is so the answer which you get, it will be 111.11 meter per second. So you have converted it. So those are V initial have converted into 11 dot meter per second. And also even the kilometer, I'll just convert the kilometer. So you have how many? 2 kilometer to make into meters, so which means 1 kilometer is 1,000. So times 2, so it will be 2,000 what? So 2,000 kilometer. That's what I do. So after you convert them, then it will be very much easy, because even the formula I showed you, the formulas which you can use to calculate the time. So you just apply the formula which I showed you last time in okay, no, you can watch our first video on projectile motion. So I have explained where the formula for time come from. So the formula for time is equal to T is equal to, which is 2h over G. So that is the formula for time. Then you just replace. So we have 2, the height is what? It is 2000. That is the height over 9 point what? The gravity is 9 point what? 9.8. Then you square root. So the time which you found here, it will be 20.25 or 20.2 seconds. That is the time which you will find. So it is simple and easy. The first question we have answered. Yes. Now let's back to our second question. So our second question is says the horizontal distance covered by the package in that time. So they want this. I explained that this is what we are calling. It is the same as what the range. This is the formula for the range. I said it is equal to we learned that distance is equal to what? Speed times time. I explained that in the video. So the formula for range which we use, we say x. So if you don't know where these formulas they are coming from, just please go to our video or the full video for projectile motion. I explained this. So v times the t. That is the formula which we are going to use. V times what? T. So our range is equal to V times what? T. So we know our V is what? So our V, we have converted it, give us 1 times, what is our T? So the T which you have from calculating it is 20.2 seconds. Then the answer, when you multiply this, it will give you 224.4 meter. So that is the answer for that question. Or you can convert this into kilometer. Still it will be, because if you are converting this, it will be what? Because we divide by 1000 here, so it will be 1 2 3, so it will be 2.24 kilometer, like that. If you want, you can convert into kilometer, it's okay. Yes. So that is the answer for the range or the horizontal displacement which they have asked us. Yes. Now let's proceed to the last question. So that question there says the velocity, the package you have halfway the height. So what will be the velocity, the package which you have the halfway is this. So that is the halfway. This is the halfway. So this would determine how can we answer the velocity for the halfway. So what should you do here for the halfway? So the first thing which we need to do here, you just divide by the height. So here what is the height? So we just divide by with him. Remember which is 2. So the height is 1000 here. 1000 what? Kilometer. That will be our height here. Bam. So if this is our height, then we just need, we don't know the final velocity here. Yes. So I can say even that we don't know here the final velocity. We can, so when we just find here the velocity which is here, and I explained in the first video on projectile motion. I was saying that when you look at this, we have here the initial velocity. It started at what? At 0. Now, until it lands, we'll assume that this will be what? Here will be our final velocity, which is at the half height. Now, they ask us to find the final velocity. That is what they ask us. The velocity of the package you have halfway the height. So, I explained that the velocity in y changes, while the velocity in x remains what? The same. So, how do we calculate they say the velocity of the package of the halfway? So, the velocity resultant, I explained this, which is the Vx squared plus Vy what? Squared. That's what I explained in our first video. Now, we know our Vx we have calculated already. We found our Vx when we answered in the range. We said our Vx, it was 1 1. So 1 1, that's what we calculated. 1 1 velocity 1 1 2. Yes, 1 1 2, that was our velocity in x. That's what we calculated. Now, what will be our velocity in y? This is interesting. So our velocity in y to calculate here, we don't know the velocity for here, because here the velocity changes in y. We don't know the velocity, but the velocity in x remains the same. But when you look at here the velocity here, which is 1.11 meter per second, that was the velocity which the x and y they add. Now for the velocity in x, it just maintains the same velocity. Yes, but while in velocity in y, it keeps on changing. That's why, because of gravity, it keeps on changing. Now we'll find the velocity here. So how can you find the velocity in y here? So the velocity in y, we use the formula for motion in one dimension, which is v squared, which is v final squared u squared plus 2as. So you are familiar with this formula. So where here the initial velocity, because before the package was falling, when the package was in the plane, before the pilot threw the package, it was not moving. So v initial velocity is equal to 0. So we just do v squared is equal to what? Which is even 2, because even I'll just square root direct like this. Even 2as, because I can just square root this. So I'll make, so which is v is equal to our 2as. So what will be our acceleration? Which is our acceleration, remember we're dealing with the gravitation field. So that will be our acceleration. So acceleration is 2gs. So 2 times 9.8. Then what will be the height? So s is represented by the height. So the height is halfway, so which is 1000. So the velocity halfway is what? When you calculate here, you find the velocity halfway, it will give you 140 meter per second. That is the velocity, right? Yes. So now the formula which we use is v. We want to find the velocity v resultant, which will be the square root of vx squared plus vy squared. So our vx, we know the vx is what? Is 111.11 squared plus 140 squared. I explained that was our initial velocity at start. Yes, for vx. When you do this, you find the velocity of halfway pack of that package will be 178.6 meter per second. So this is simple and easy. So we have calculated all these questions without difficult. So this question is simple and easy.